Good evening. My name is Alistair Landels and I work for OCAD. And today I'd like to present the topic, what does it take to make a multi-platform mapping app? Today's presentation is in two parts. Firstly, looking at the requirements and the design decisions we made in preparation for building the new app. And then secondly, we'll have a look at the GPS tool. And then we'll finish off with some questions and answers. So there's many requirements for building a modern app. So it should be multi-language and the user interface needs to be configurable. But the main focus is that to try and maximize the productivity of the user in the field. Building an app like this is quite challenging because it's like building a CAD app on a telephone. So while you've got fingers and stylus, there is no keyboard. You also need to utilize other things on the device, such as GPS and compass. And lastly, we wanted it to be based on the Sketch app concept, which was produced by OCAD 3 years ago. So the app we've built can run on Windows, Macintosh, Android and iOS, although initially it's only going to be released on the last two. One really important requirement that we have for the app is that it needs to be able to be used offline so that a user in the forest without internet connection can still work productively. Also, the other requirements are often users might have multiple devices, or you can have projects with multiple mappers who will want to submit data back to the main map. And then, of course, there's devices of different sizes and obviously portrait and landscape to all present other challenges. And then after working in the field, it's important that when the user needs to submit their data, that it's seamless and easy for them to do so. And we also have some conflict management functionality which were built into the desktop to manage multiple data sources. Some other requirements is obviously it needs to be able to use existing standards such as the current OCAD file. And then of course there's rendering issues to deal with. We need to be able to render geometry, so when you're zooming in and zooming out, that the map objects look good, and to be able to edit those geometry objects. And then of course there can be hundreds or even thousands of these objects on the screen at once. Then we also have other layered data, such as LiDAR data or aerial photographs, etc. And these maybe need to be semi-opaque or transparent. And then lastly, being an editing application, you need to be able to have undo and redo and be able to handle large transactions, for example, when you're moving or deleting a large number of objects. So some of the design decisions we had were that it needs to be good performance, so we need to run native code on devices. It also needs to be able to run offline, so it's not really suitable for a web interface. And then we also need to use software from a reputable software supplier. We need them to be around in 30 years' time in the same way that Delphi is still around, which is what OCAD Desktop's written in. Needs to be able to run on, the software needs to be able to run on multiple devices, and obviously a modern programming language would be also great. So the software we use to build the app is Microsoft's .NET MAUI. It uses the C# language. It's only been around for 4 years, but it's built on top of .NET and C#, which have been around for 25 years. It means we can have a single code base, and we can generate runtime code that can run natively on the various platforms. It also integrates well with the iOS and Android app stores, so we can deliver runtimes directly to the stores, and then they can be uploaded or downloaded by users. And obviously it also has inbuilt functionality for compasses and GPS, etc. And there's multi-language support. We also make use of a few components. Two of the more important ones are Google's Skier Sharp rendering component. This is what we use to draw the map. And we also use that component for drawing other graphical elements, such as the icons, which are resizable. We also use a database on the device, and we use one called SQLite. It's a file-based database which supports transactions and write-ahead logging, etc. And then there's some other open source components which we use. And there's also support from the .NET community. And they even have a toolkit which we use many of the components from. Next, I'd like to talk a bit about the GPS tool, which is a tool in the app which we wrote to make it easy for the user to register data where they are or as they move around. So we wanted to make it easy for the user, intuitive to use, so very few buttons. But at the end of the day, we wanted to produce some sort of geometry which the user can then edit easily afterwards. And at the same time, while this tool is recording, the user should be able to continue to draw or sketch other things as well. So we wanted to design a user interface where the user could change their mind while they're recording, to change from a sketch to a symbol, or to be able to change the symbol itself, maybe to a different shade of green or a different type of track or something. Also, sometimes maybe they want to use curves, or maybe they want straight lines. And if they do use curves, then we want to be able to smooth those curves and convert them into Beziers. So I've got a little demo here, which I'll talk through as I play it. So we're going to select a red sketch symbol, and it's going to start recording now. And then on the way, just going to draw a green cross and continue on. See me adjusting the smoothing there a little bit. Draw a black circle. I'm going to change to a railway symbol instead of a red sketch. Again, you can adjust the smoothing and use straight lines rather than curves. I'm going to draw a couple of blue squares and a green area off to the right, also while we're still recording. I'm going to pause recording now and go for a walk south here to draw a boulder, and then walk back again. And then I'm going to restart the recording. There's a small glitch there in the geometry. We'll fix that afterwards. When we get to the end, maybe draw another tree. It's still recording. And maybe draw another green area. And then we're going to change symbol to a fence. And again, play around with the smoothing, maybe make it curved a bit. And then we're going to finish now. But then we're going to click on undo, because actually I don't want it to be closed. Adjust the smoothing a little bit. And now I'm going to finish the geometry. And then I'm just going to go in, zoom in now, and actually fix the geometry of the thing I've drawn. So adjust the Bezier point. And we're all done. So here's a diagram illustrating the architecture of what we've just seen. So there's a point service here on the top left, which is feeding data to basically a motor here. And what this does is it uses the user's preferences of symbol and smoothing factor, curve or straight, etc. Into this, and then it processes the data through some algorithms, and then basically generates an image which then gets rendered onto the map. Then obviously once they've finished recording, they will want to stop, and then again you tell the motor to generate the result and store it, and obviously then update the map with the new feature. And also, while this is going on, the user can continue to edit and select other things and draw new things. So we use 3 different algorithms to process the data. Firstly, we use a secondary sort of filter to remove any close points along straight lines, for example. And then we use something called a Raman-Douglas-Pipka algorithm, which will simplify the shape once more using some other types of tolerances. And lastly, we do a Bezier conversion, where we take the polygon and calculate the control points for the Bezier curve. And then that's the data that is then stored. So that's a little bit of information about how the GPS tool works. And to finish off with, I've just got a very short video demo, which went mostly well. There's a big clearing here. Thanks for watching today, and the app will hopefully be released in the next few weeks to an app store near you. Thank you.